Okay, Year 12, I'm going to go through the work that we did today. And we're doing probability density functions and cumulative distribution functions. So let's just go back over and have a look at what each of these are. So I'm going back a few exercises. So when we look at a probability density function, so if we go right back here to what a probability density function is. So if you get given, I don't know, a function, and the area under that function, the area under that curve for whatever domain, if that equals 1, well then it satisfies the conditions of a probability density function. So for example, here are some here. And this could be, although it's not because it's going from 1 to 7, the probability of these events here all equal a 6. And I know that this distance is 6 and that height is a 6. So 6 times a 6 equals 1. So that's a probability density function. This one isn't, because that's 12 and that's a tenth, and 12 times a tenth gives me 1 2/10. Now, so this could, if these two parameters were, if it went 1 to 0, 1 to 6, 1 to 6, we'd have the one for rolling a die. So a probability density function is just a function under which the area of the curve equals 1, or that function. Now, why do we use it? Because for some of these, for discrete probabilities, particularly in these cases, in question 3, it's pretty easy because we don't have to integrate or do anything like that. But if we get a probability density function, there's a quartic, there's a cubic, and there's an x squared, finding the area under those is difficult. And what we're going to be using these for is continuous data, not discrete data, but continuous data where it's difficult to find the area, the discrete possibility, the discrete probabilities in the areas under those curves. So what comes next? Oh, and by the way, a uniform one is just where the probabilities are all the same. So it's a straight line. All those square ones, they're all uniform ones. The probabilities are all the same. This one is uniform, probabilities, and that's for rolling a dice. This one, well, that's not uniform. The probabilities change. Okay. So what is this thing? Well, the cumulative distribution function is what you get when you integrate, because you don't want to be integrating these things again and again and again, especially if you're doing a lot of probability calculations for one function. So you just want to integrate it once, and you go from x to the lowest level, you get a function, and you can then calculate probabilities, and you can find certain values. So let's go to today's exercise, which is 1404. And then we're going to talk at quantiles. I'm going to come back to that. The first thing I want to do is I want to look at this. Now, they really should say that, and look what we're doing. We've got continuous data, so it's not discrete, and they give us a function. Well, the first thing they give us, and we'll take this one here. So this is question 1a, and they say f of x equals 3x squared on 511. And they say it's for a set domain from 1 to 8. So there's the domain. And what is that? Well, that is, and they haven't stated it, that is a probability density function. Usually they will say this is a probability density function. And if I look at some of the other questions, hopefully they've defined it. They call it a continuous probability distribution. Okay? So let's go back to this. There's our probability density function. It's called f of x. Now, if we integrate this, if we integrate f of x from the minimum, so this one here, so from 1 to x, because we want an x function with respect to x, we will get a cumulative distribution function, which will tell us the probabilities. Will tell us the probabilities for the probability density function. And we've done that. So if I integrate that, and I'll get a single function, so the integral, so I've got to do the integral from 1 to x of 3x squared on 511 dx. Okay, well, what do? I add 1 to the power, 3x cubed on 511, and I divide by 3 underneath, which is really handy, and I'm going from x to 1. Okay, those 3's will cancel, so it didn't change anything except the power. I've now got x cubed on 511 between x and 1. I substitute that in, and I'll get x cubed on 511 minus 1 cubed on 511, which gives me x cubed minus 1 on 511. And remember, this is our cumulative distribution function. It's going to tell us the area under the curve for whatever values we put in for x. We don't have to integrate it again. We've got it. There it is. Now, what can we use it for? Well, we can use it for calculating the probabilities of this function between whatever values we want. But we can also, because it's cumulative, we can also use it to calculate these sorts of things. Quartiles, percentiles and deciles. And more important, also the median. So let's look at how we calculate the median. Well, the median is halfway. So halfway in this probability distribution table, which adds up to 1, will be 0.5 or a half. So here they've calculated the CDF. There it is. There's the cumulative distribution function. And for the median, they've put that equal to 0.5. Okay. Let's go back and have a go at it. So I've got my CDF. I want to find the median. Well, the median will be when the CDF equals a half. You can write a half or 0.5, it doesn't matter. So that means x cubed minus 1 on 511 has got to equal 1 on 2. I multiply the 511 across. X cubed minus 1 equals 511 on 2. X cubed equals 511 on 2 plus 1. Note that I'm not worrying about making it a proper fraction because I'm just going to pump this into my calculator. Because it's continuous data, it's continuous data, I'll get a decimal. So I'm not that fussed. So now I cube root all of that, 511 on 2 plus 1. And I go to my calculator, which I've got to open. Oh, hold on. It was right there. There we go. And I get it up. So what do I want? I want the cube root of 511 on 2 plus 1. And make sure that 1 is under the square root. Now, 6.35, because it's continuous data, 6.35. Now that answer is correct, but, and you know that from the back of the book, but remember your answer has to be between or somewhere within the domain. If you get an answer that's outside 1 and 8, well, you're wrong, because a median must be somewhere in that domain. Now, I'm going to do J, all right? And when I do J, it's a little bit harder, and it's going to revise some things that we need to remember. So let's go 1J. Now again, we get given f of x. So what's f of x in J? F of x equals x squared minus 3 to the 3 over 3, 5, 7, 0. Now that is a probability density function. We need the CDF. So we're going to integrate f of x. Oh, hold on. What's the domain? From 1, hold on, from 2 to 4. So the domain is 2 to 4. So we're going to go x to 2 of f of x. So that's the integral of x squared minus 3 cubed 3570 dx from x to 2. Okay, so this is a bit harder, this integration. And some people have real worries about this 3570. So I'm just going to take that out the front because it puts people off. You can take it out. It's a constant. It's multiplied. So 1 on 3570. X on 2. X squared minus 3 cubed dx. Now, you should remember on your formula sheet, and I wonder if I've got, well, I haven't got one handy, but the integral, it says, of f dash of x, f of x to the n. I'm just going to check and make sure I've got it right. Dx, so this is on your formula sheet, equals 1 on n plus 1 f of x to the n plus 1, plus a constant, but because we're doing it within limits, we don't need that. So this is almost, look, the derivative of the function to a power. Well, I've got this function to the power. What's the derivative of x squared minus 3? Oh, it's 2x. I've only got x. But it's a constant. So I can put 2 in as long as I take 2 out. So put it in, take it out, do the hokey pokey, and the integral will come out. So now Now I've got the derivative. So outside, I've got 2 times 3570. So 2 times 3570, that's outside. So 7140. So I've got 1 over 7140. And now x to 2x, x squared minus 3 cubed dx. Now realise I haven't changed the integrity of this. I've just manipulated it so I get the derivative outside the function. Now I can integrate it. So 1 on 7140, and our formula says, add 1 to the power and divide by it. So I get a quarter. I'm going to put this in parentheses, but I can take it out, and I will in a minute. And then this function raised to the power of 1 more. So x squared minus 3 to the 4 between, and I don't need the plus c because I've got parameters, and I'll take that quarter out. So when I take that quarter out, I'm going to get a really big number here, but that's okay. I'm not fussed about that. So I'm going to get 1, and now I'm going to go 4 times that, times 4, 28560, 28560, and I've got x squared minus 3 to the 4 between x and 2. Now, all I've got to do is sub the values in. So I get 1 on 28560, x squared minus 3 to the 4 minus 2 squared minus 3 to the 4. And that gives me 1 on 28560, x squared minus 3 to the 4 minus, well, 2 squared is 4, 4 minus 3 is 1, and 1 to the power 4 is 1. All that sits on top of this fraction now. I can leave it like that. X squared minus 3 to the 4 minus 1 on 28560. And that is our CDF. That's going to tell us the sum of the probabilities anywhere along this curve. It's a cumulative. Now we need to find the median. Well, the median is when the CDF, the median is when the CDF equals a half, halfway along. You can write 0.5 if you want. So x squared minus 3 to the 4 minus 1 over 28560 equals a half. I like working in fractions. You can use decimals if you want. I'm going to multiply that 28560 over. So x squared minus 3 to the 4 minus 1 equals 28560 on 2. I'm just going to leave it like that because I'm just going to do a calculator at the end. I have to add 1. X squared minus 3 to the 4 equals 28560 over 2 plus 1. Have to get rid of that fourth, so I'm going to fourth root it. So x squared minus 3 equals the fourth root of 28560 over 2 plus 1. Making sure that plus 1 is under the radical sign. Now I'm going to add the 3. X squared equals the fourth root of 28560 over 2 plus 1 plus 3, but making sure that 3 is outside that surd. Now I have to square root everything. So the square root of the fourth root of 28560 0.560 over 2 plus 1 plus 3. Realise that 3 is under that radical sign there. Now it's just calculator work. Now in my head, I need to remember that my domain is between 2 and 4. So I need to get an answer when I do all this between 2 and 4. So I need the square root of the 4th root. So I have to go shift here, put a 4 in there, get inside there, put a fraction, 28560 over 2. I have to get out of there and I have to have a plus 1, which is under that sign, but I then have to get out and add a plus 3, but that's under the big radical sign. So just type it all in one go. And remember, I need an answer between 2 and 4. 3.73, which is good because it's between 2 and 4, but I'm just going to check the answers now. And hold on, I've got them up here. Question J, HI, come on, where are you? J, 3.73. So that was really hard. Well, not really hard. Well, it was a little bit, I suppose, but it required a hell of a lot of work. So when you're doing questions 2 and 3, they ask you to find percentiles and medians and third quartiles. So I'm just going to do 2A. So I've got to find the first quartile, the second decile, and the 77th percentile. And I got 3x squared on 973. So let's take that one. So this is 2A. 2A. And what am I finding? I've got the questions on my other one. I need the first quartile. Okay, Q1. I'm finding the second decile. And I'm finding the 77th percentile. And my equation, my probability density function, f of x, equals 3x squared on 973. Oh, come on. And that's for a domain between 3 and 10. So all my answers have to be between 3 and 10 for those three there. So the first thing I have to do is find the CDF, the cumulative distribution function, which is just the integral from x to 3 of that thing there, 3x squared on 973. And this is going to be good because when I raise it to the power, we get 3x, add 1 to the power, 973, and divide by that again. And we go in between x and 3. And those 3's are going to cancel. So this is nice, quite like the first one in question 1. And I get x cubed on 973 between x and 3. I substitute those values in. Well, that gives me x cubed on 973 minus 3 cubed on 973, which gives me x cubed minus 27 on 973. So that is my CDF. Once I've got that, I'm going to use it to answer these three questions. So the CDF equals x cubed minus 27 on 973. So the first one, I want to work out Q1. Well, Q1 is 25%, 0.25, 25 on 100, or better still, a quarter. So x cubed, so here's part 1, for Q1, x cubed minus 27 on 973 equals a quarter. Multiply the 973 across, x cubed minus 27 equals 973 over 4. Remember, I'm going to do it all on my calculator. X cubed equals 973 on 4, add the 27, and then cube root the whole lot. X equals a cube root of 973 over 4 plus 27. And then it's just calculator work. So here we go. Let's get the cube root. Fraction 973 over 4. Get outside of that. Plus 27. 6.46. 6.47. 6.47 is Q1. Let's check it. I'm just going to get the answers up, which are over here. So 2A, 6.47. Now, we need to find the second decile. So number 2, the second decile is 20%. Now remember, you can put 0.2, you put 20 over 100, so you know 0.2. 20% is a fifth. I just like working with fractions. So x cubed minus 27. Remember, it doesn't matter if you've used a decimal. 973 equals a fifth. Multiply the 973 over x cubed minus 27 equals 973 over 5. Add the 27. X cubed minus 27. Equals 973 over 5 plus 27. And cube root the whole lot. Calculator work again. Oh, I just need to change that 4 to a 5. 6.05, which is correct. And I've approximated these, I've rounded. Hey, here's an interesting thing. I could have gone just straight to there. Yeah, you could have, but it's better to show you're working. Let's go to the last one, 77%. 77 percentile. I write percentile because percent. The 77th percentile. So you can use 0.77. You can use 77 over 100. I'm going to use the decimal this time just in case you've been using it and you're wondering and you haven't been getting the same answers. Let's see. X cubed minus 27 over 973 equals 0.77. Multiply that 973 over. So x cubed minus 27 equals 973 times 0.77. Add the 27. X cubed equals 973 times 0.77 plus 27. And then cube root the whole lot. X equals the cube root of 973 times 0.77 plus 27. Again, calculator work. I'm not going to replay. I'm just going to do a new one. So cube root 973 times 0.77 plus 27. 9.19 which is correct. So if you use a fraction or a decimal, it doesn't matter. Just be good with your calculations. So that is enough, and you need to make sure that you're able to do these for class. Good luck.